Hello everyone, welcome back to my YouTube channel. Today we are going to study about a new topic that is chemical energy, or some textbook call this topic as thermochemistry. From the title we already know that there are two words. Thermo means that temperature and chemistry in chemistry. So in this topic we are going to deal with the temperature. But anyway, for the highlight in this page, I'm going to introduce you to 4 new terms, that is system, surrounding, enthalpy, and enthalpy change. Don't worry, this topic is really easy and it's very fun because at the end of this topic, I'm going to give you some experiment that can be done at home. Well, but before that, I wish you have well understanding for the theory first. Well, let's say we have a bigger glass here, and then we have magnesium ribbon, and then we put the magnesium ribbon into the bigger glass, and then we pour the hydrochloric acid with the concentration is 1 molar into the magnesium ribbon. And then we stir it and we check the temperature using thermometer. So before, you need to check and record the temperature of initial hydrochloric acid before you mix it with magnesium ribbon, and then the final temperature. It means that after you mix both magnesium ribbon and hydrochloric acid, then we're gonna see the changings of temperature. Well guys, now I'm going to discuss about the first term called as system. System is everything that we observe during the reaction conducts. During we have the experiment, what do we observe? Well, we have bigger glass, and then what are you going to observe? Of course, you're gonna observe the reaction between magnesium ribbon and hydrochloric acid. Is there any color changing? Is there any changings of temperature? Is there any bubble gas form? And so on. So from this situation, the things that we observe called as system, you can mention. Well, we're gonna observe the magnesium ribbon when it will use up, and then we're gonna observe the hydrochloric acid, and then of course we can observe the changing of temperature. So we can say that there are 3 systems in this situation: magnesium ribbon, thermometer, and hydrochloric acid. How about spatula? You don't need to observe it during the reaction happen. Am I right? Yeah. So surrounding, we can say it as out of the system. Out of the system here is there is spatula or probably there is something else on the table. Out of the system, we call it as surrounding. So in this case, the surrounding is spatula and also the wall of the bigger glass, but outside, in the outside part. But in the inside part, it's still called as the system. Well guys, now you already have well understanding about system and surrounding. I am happy. Next, from this situation, the chemical equation is magnesium ribbon, it is solid, plus 2 hydrochloric acid in liquid will obtain magnesium chloride or in solution, and it will produce bubble gas called as hydrogen gas. Then we go to the third term, enthalpy, or the symbol is H. What is that? The energy stored in the system. So there is energy or there is heat inside the system, whether inside the reactant or in the product. We call it as enthalpy. Like inside your body, you have energy or heat inside your body. Your body is the system, so we call it as enthalpy. Next, then what is enthalpy change? Or the symbol is delta H. So the symbol, you can pronounce it as delta H. It is the change in energy going from reactants to products. So later on, we can observe how many energy change from reactant to the product. So the changings we call it as enthalpy change or delta H. We can classify enthalpy change into two, whether it has value positive something kilojoule per mole or negative, positive or negative. So because there are two signs of enthalpy change, whether it is positive and negative, so we can classify the reaction into two parts. The first reaction is exothermic reaction and endothermic reaction. What is that? Well, exothermic reaction, the energy will given out from the system to surrounding. So the circle is system, and then out of the system is surrounding. So the heat or the energy is given out from the system to surrounding. So it will make the temperature of the surrounding will be hot. So if you touch the bigger glass, outside of the bigger glass, the temperature will be hot. Next, where endothermic reaction, the system will absorb energy from the surrounding. So if you have any questions, how come the system and surrounding will release or given out energy or absorb energy? Yeah, this is the idea. When a chemical bonds are formed, heat will be released. But when chemical bonds are broken, heat will be absorbed. So that happens in chemical reaction. Well, in endothermic reaction, it's very simple to investigate whether your reaction is endothermic or exothermic. When you touch the bigger glass, outside of the bigger glass, the temperature will be cold. Okay, guys. For example, the example of exothermic reaction, here is the combustions. We have learned this before. Methane plus oxygen will produce carbon dioxide and water plus heat. It means that heat is released. Look at the position of the heat is in the product. But the example of the endothermic reaction is photosynthesis. 6 carbon dioxide plus 6 molecule of water absorb heat. Look at the position of the heat is in the reactant. Will produce glucose and oxygen. Well, we are going to discuss about the diagram level between exothermic and endothermic. So this is the diagram level. So the y-axis is labeled as potential energy. The unit is kilojoule, kJ, kilojoule, while the x-axis is time in second. In the case of exothermic reaction, the reactant are at higher energy level as compared to the product, as shown here. In other words, the product are more stable than reactant because the energy is lower than the reactant. So, the difference between reactant to the peak means that the transition state, we call it as activation energy or EA, where the difference between reactant to the product, we call it as enthalpy change, because the reactant higher than the product, then the enthalpy change will have sign negative x kilojoule per mole. Okay, reactant minus product. Where in endothermic reaction, the diagram level y-axis labeled as potential energy in kilojoule and x-axis labeled as time in second. In the case of endothermic reaction, the reactants are at lower energy level compared with the product. So the difference between reactant to the transition state, the peak, is activation energy or EA, where the difference between reactant to the product, we call it as enthalpy change or delta H. The sign is positive X kilojoule per mole. So the meaning of positive here is absorbed energy, where the meaning of negative value here is release energy or heat, where this is the general formula for the calculation of enthalpy change. The sum of enthalpy change bond broken usually happens in the reactant, minus the sum of enthalpy change in the bond forming or in the product. So for the calculation, I'm going to teach you in the next video. And please check your Moodle, because I already give you something surprise to be done, the experiment that you need to be done at home. Don't forget to ask your parents or someone to accompany you to do that experiment. That's it for our today's lesson, guys. Stay safe and God bless you.